The proposition of Jupiter igniting into a second sun invites a high-impact reimagination of cosmic order, challenging our assumptions about stability, resilience, and the built-in conservatism of planetary ecosystems. Turning a gas giant into a shining companion star isn't just a shift in illumination. It's a complete operating model disruption for the solar system. It forces Earth and everything attached to its strategic equilibrium to renegotiate the terms of existence. From orbital dynamics to biological architecture, from atmospheric chemistry to socio-political decision-making, the system is pushed into a corporate-scale transformation with no precedent in natural history. At its core, the idea requires a radical development. Jupiter crossing the threshold from gas giant to brown dwarf-like radiance. In physics, this means a reorganization of mass, pressure, and ignition conditions far beyond what the planet currently possesses. Jupiter lacks the raw weight to trigger hydrogen fusion. It is a failed star, a prototype that did not secure the capital investment needed for ignition. But for the purpose of this hypothetical, assume the requirement is met. Through unknown forces, spontaneous mass accumulation, exotic physics, or cosmic intervention, and Jupiter becomes luminous. Not a second sun matching our own, but a balanced substellar companion delivering sustained light and heat. This immediately triggers a two-star operating model, a binary system that shifts the gravitational architecture of every planetary asset. Every orbit that once depended on a single anchor is now recalibrated by dual influence. Earth becomes a stakeholder in a new gravitational budget, pulled gently but consistently by a light-bearing Jupiter that no longer blends quietly into the night sky. Instead, it casts an unwavering glow, repositioning itself as a strategic force in the solar environment. The first visible change manifests in the sky. Nights become brighter, losing their traditional darkness and gaining a twilight-like wash powered by a soft gold or deep crimson glow, depending on Jupiter's temperature and luminosity. The cultural impact is immediate. Civilizations that have used darkness as structure, for rest, for ritual, for contemplation, now operate within an extended light paradigm. The traditional cadence of night and day becomes blurred, and societies must re-engineer behavioral expectations. From circadian cycles to agricultural timeframes, from religious symbolism to geopolitical security protocols, humanity adapts to a sky that refuses to fully dim. Astronomers would quickly reclassify Jupiter not as a planet but as the solar system's junior star. Its mass remains the same, but the ignition event forces rethinking of old taxonomies. As Jupiter settles into its role as a dim but steady second sun, Earth enters a phase of deep structural recalibration. The new light source doesn't overpower the primary sun, but it injects a strategic layer of energy that reshapes environmental, biological, and economic systems at scale. This is not a doomsday pivot, it's more like an aggressive market disruption, a second illumination channel forcing everything to rethink its operating assumptions. The first major shift unfolds in Earth's oceans. With Jupiter's glow delivering incremental heat across the planet's night side, temperature differentials begin to shrink. Ocean surfaces warm more uniformly, reducing the stark contrast between day-heated and night-cooled waters. This softens some traditional current patterns while supercharging others. The Gulf Stream strengthens, the Arctic circumpolar vortex weakens, and newly exposed polar waters support richer biological productivity. Marine life migrates aggressively, following the warmer ribbons of water threading through the Atlantic and Pacific. Entire fisheries move poleward, triggering geopolitical negotiations as nations redefine maritime boundaries that were once stable for generations. Atmospheric systems echo the same trend: more energy, more motion, more volatility. With nights never fully dark or cool, heat doesn't dissipate at historical rates. Storms form faster, expand wider, and sustain longer lifespans. Monsoon cycles intensify in some regions and falter in others. The jet streams, no longer guided by sharp temperature gradients, wobble unpredictably, driving extreme weather into regions once known for stability. Cities that once planned infrastructure around predictable climates must shift into high-agility mode, adopting architectural resilience strategies, reflective rooftops, green corridors, heat-absorbing facades, and flood-adaptive drainage systems. Human physiology experiences its own recalibration. Extended exposure to low-level illumination subtly disrupts melatonin production, making natural sleep cycles harder to maintain. The traditional night becomes a strategic commodity. People adopt blackout environments, sensor-driven lighting controls, and sleep pods engineered to simulate pre-ignition darkness. Corporations roll out circadian stability programs, recognizing that a globally fatigued workforce threatens productivity and decision-making. Wellness becomes a competitive advantage, and regions with naturally deeper shadows, valleys, mountainous basins, areas farthest from Jupiter's direct line of sight, quietly gain real estate value. As Earth stabilizes under the dual light framework, humanity begins shifting from reactive adaptation to long-term strategic planning. Jupiter's steady radiance becomes more than a cosmic anomaly. It evolves into an asset that redefines humanity's risk posture, growth potential, and exploratory vision. The solar system transforms from a single-core model into a distributed energy network, offering opportunities that fundamentally realign civilization's ambition. The first frontier is space infrastructure. With Jupiter now emitting usable light, its orbit becomes a high-value expansion zone. The Jovian moons, once reliant on nuclear or chemical systems for power, enter a new economic life cycle. Europa's surface warms just enough to support large-scale solar installations. Ganymede's magnetic field becomes a promising anchor point for shielded habitats. Callisto transforms into a logistics hub, a stable, low-radiation waypoint enabling sustained deep space operations. Corporate and national agencies alike pursue aggressive resource development charters, unlocking water, minerals, and scientific insight at unprecedented scale. Back on Earth, society recalibrates how it thinks about stability. The traditional boundary between night and day dissolves into a concept of light zones, each offering unique productivity patterns. Urban planning evolves around dual illumination flows. Agriculture becomes a precision-engineered ecosystem powered by continuous photosynthetic potential. Energy markets flatten as solar generation becomes nearly round-the-clock. Even cultural identity shifts. Humanity begins seeing itself as a two-sun species, shaped by an environment richer, brighter, and more complex than any generation before could imagine. But the deeper impact is psychological. The presence of a second sun subtly expands the human sense of possibility. With more light, more heat, and more habitable zones emerging across the system, humanity sheds the old fear of cosmic fragility. The universe feels less cold, less empty, less distant. Jupiter's ignition becomes a symbol of renewal, a reminder that environments evolve, and so must civilizations. In this new two-star reality, Earth doesn't merely survive. It scales, diversifies, and redefines its place in the cosmos, stepping confidently into a future illuminated from two directions. If Jupiter became a second sun. Part 4. The new balance of power in a dual sun era. With Jupiter's glow fully integrated into daily life, humanity moves past survival mode and embraces a new era of strategic recalibration. A two-sun environment doesn't just reshape nature, it redefines influence, leverage, and competitive advantage across the globe. This shift forces governments, corporations, and scientific institutions to reassess their long-term playbooks. The geopolitical balance tilts in unexpected ways. Regions traditionally locked in freezing climates suddenly become prime real estate. Northern Canada, Siberia, Scandinavia, and parts of Greenland experience extended growing seasons, milder winters, and unprecedented agricultural potential. These territories, once considered peripheral, surge into economic relevance. New trade hubs emerge at higher latitudes, and once frozen shipping routes along the Arctic become permanent global arteries. Nations controlling these corridors gain outsized influence in logistics, energy transit, and food supply resilience. Meanwhile, equatorial and tropical regions confront mounting operational risk. Rising temperatures strain water availability, infrastructure reliability, and public health systems. This doesn't trigger collapse. Instead, it demands aggressive strategic pivots. Megacities invest massively in climate-adaptive architecture, heat-resistant materials, vertical green walls, shaded supercorridors, and underground transit designed to reduce thermal exposure. Innovation becomes a necessity, pushing local industries into leadership roles in environmental engineering, heat-resilient agriculture, and atmospheric management technology. Economically, the dual sun era ignites new competitive sectors. Solar plus systems, designed to harvest both solar inputs, become the backbone of the global energy ecosystem. Robotics manufacturers thrive as nighttime outdoor operations become easier in Jupiter's glow. Telecommunications expand into the Jovian system, establishing relay networks that support research outposts and industrial bases orbiting the new substar. Entire supply chains rewrite their frameworks around extended illumination cycles, optimizing productivity in ways impossible under a single sun model. Socially, humanity matures into a species accustomed to perpetual twilight. Artists reinterpret shadow and color. Religions reframe their cosmology around a universe with dual light sources. Education systems integrate the physics of binary illumination into foundational curriculum. Ultimately, Jupiter's ignition becomes the catalyst for a more diversified, distributed, and forward-leaning human presence. The world doesn't lose itself, it reinvents itself, standing more confidently in a solar system that now offers to centers of light, to symbols of possibility, and an entirely reshaped horizon.